to this Dassault Systems 30-minute webinar, Considerations for Your Future Factory Strategies. This is part 2. Let us welcome Enrico Scharlach. Enrico is our Aerospace and Defense Industry Solution Experience Director, and he leads strategic direction for our manufacturing solutions. Enrico has worked with Boeing as a manufacturing solution architect and many of our customers on process planning and manufacturing strategies. Welcome, Enrico.
Thank you very much, Ellen, and welcome everybody to the webinar part 2. If you missed part 1, I would appreciate if you go back and watch part 1, but at the beginning I have a little bit of a summary of what we discussed in part 1, where we discussed the way we want to drive innovation in the industry to achieve the goals of the production environment and the systems in the future factory. So a short summary, what we started 4 years ago is to define and build out the industry experiences based on the business processes and the standards in aerospace and defense to drive the end-to-end processes from the beginning of a concept of requirements throughout production and the support and services. We then sat back and thought about how can we help the industry to accelerate and drive their ideas, their strategies, their vision of the factory of the future. And we decided to invest and build up innovation on 3D experience centers around the world, which is a collaborative environment with the latest and newest technology available to envision, but also define and test run your factory of the future. So, and to scale and to leverage all the great knowledge around the world, we are setting up a network of innovation centers, not only in North America and Europe, but also in Asia and in South America, accelerate and drive the innovations and the technology and the continuity, the digital backbone of it. So talking about technologies, there are plenty of new technologies out there and there are more to come. It's really, really exciting to see and dream about what could be the factory of the future. But the real benefit is, the first wave of benefit is when we are able to connect those technologies together and create experiences that people can really leverage and use it to be more efficient, to be safe in such an environment. But essentially, this should be all connected to a factory of the future environment, to the digital system underneath, to a platform which provides you the digital continuity of all the data from the beginning to the end and looping through to continuously optimize based on the feedback we get from the execution. So how can you imagine such place, such an innovation center? This gives you an idea of a short layout of NIAR in Wichita. We have, besides customer collaboration rooms, we have large VR and augmented reality environments where you can collaborate, you can test run in a virtual setup before you take it into the real. And MRAM, and I will get to that in more details, for multi-robotics advanced manufacturing, to do really a flexible, hybrid, automated production, large capabilities on 3D printing and additive manufacturing. And this is what I want to take and start to give you some more details and do a deep dive on what is out there, what we do, and how it can help you. So on the additive manufacturing, this is a technology which is out there for a long, long time. Think about composites, additive manufacturing, and we learned a lot from that. But now with the 3D printing capabilities, or even if you leverage the design optimization for milling, this is giving you much more benefits in the future when it comes for production and the materials you save, but also in your end products for weight and stiffness and durability. As I said multiple times, such a technology of printing parts, different materials, is as perfect as more you have visibility from the beginning to the end of the process underneath it. And the technology starts when you think about the powders and materials you're going to print. You better understand how the materials perform and behave, how on an atomic level it is structured, then you exactly know how to print. There's a lot of focus on the generative design, how to create those parts you could have never designed before manually. Yeah, but it is really the end-to-end process, and this goes from design also to the manufacturing. And to give you a little bit of an idea, what does it mean to really evaluate not only the design and the structure of a part and the physics behind on the stress, but also looking at the printability, because this is where at the moment there's a lot of waste that parts which are designed and look just gorgeous cannot be printed. So here in an immersive environment, like you see here, we define the powder, the machines, and with all the parameters of the machine, the tray tables, to then go and validate what is the best strategy and process to print the part. Or, I mean, at the end, if I figure out I cannot print it, then I have to go back to the design. And this goes through different kind of process steps, which are common here for aerospace and defense parts, defining the support structures, but also doing the physics and the simulations during the print. Especially when you have complex and larger parts, you want to know that how the printed part behaves during print, the impact of heat, the distortion, deformation of the print, to optimize it right here. Yeah? Maybe there's a better solution to hit it with a different angle, what we see here. And I want to figure that out in my virtual environment. I don't want to try and error on a printing machine. This machine is way too expensive, and the material and powder is way too expensive. And I want to leverage automated processes here in that case to continuously run my simulations and the parameters in the background to optimize that 3D print. So when we look at what we want to drive and the benefits at additive manufacturing, which you can do in the lab, is really to support to get this technology into rate production, because this makes our aircraft and system greener, lighter, stronger, and cheaper at the end. And we want to do this rapidly. Okay, to have the printed as designed and as the requirements, because then I can certify it and be sure that whatever I design is really coming out at the end, so that the authoritative certification can be done. And then for sure, I want to reduce the time to going throughout the iteration, which goes back to webinar number 1. Talked about the flexibility of changes and implementing them rapidly. Second focus is on immersive engineering and manufacturing systems. This is also technology which is out there since a while, but it's getting better and better. It's on the virtual reality side with the large caves or power walls. It is really a way to collaborate and review and experience it in an immersive way of your design, and that's what we see here in this case, to review the design and really experience it, or to go and do a detailed review. Take your colleagues into the cave, share this experience with other experience centers around the world. You have those power walls or caves in different innovation centers, and then you can do this in immersive technologies, use that to validate what you're really doing, and drive that into manufacturing. And this is when you do the design and the planning and simulation of your production environment. Use those immersive technologies to validate, to review, to get your production people going with you, and going through your factory of the future. See exactly how things are supposed to be, overlay it how it is at the moment, or to build and define your future factory. So again, This technology is there. It is really meant to accelerate and produce better quality at the end. And this is identifying risk in a virtual environment before I drive it into production, and being there and leveraging all the knowledge on how to implement the requirements and concepts which are proposed, and then take it over in real production. Next is the hybrid manufacturing and the MRAM, the multi-robotics advanced manufacturing. And this is really something which will drive our future production systems. Those robotic cells include different kind of robots, different kind of production technologies. We see here 3D printing from the top and surfacing from the robot in front. In the same cell, we have handling robots, we have inspection robots. You can do assembly, can print and paint. But what is key is when we have those flexible production lines for this hybrid manufacturing, that you can program and simulate and validate any kind of change and reset up rapidly. And traditionally, the setup and programming of such robot cells with 6 or 8 robots and different technologies took weeks and months. We want to take it down into a week of a time frame that you set up your cell, you define the processes and the robot program, you simulate, verify, and optimize, and then you just send it to your robots and you execute. This is really the target. And to give you some more perspective on the MRAM cell at NIAR, I would like to show you the following video.
With the world's largest multi-robot advanced manufacturing lab here at the 3DEXPERIENCE Center with NIAR, we are not only programming, validating and optimizing the robot cells in a virtual world, we also execute, track the data and analyze the results of the robots to continuously improve the cell performance of this automated line. New innovation processes for line automation can here not only be validated and tested to a confidence level, our customer can take the results out of MRAM, implement in their production environment to drive at production rate and first time quality. With manufacturing 4.0 and hybrid production systems, MRAM is driving the way how new UAS, satellites and other systems are produced, fully automated and in a much shorter period of time.
So summarizing the values and the target of the future factory hybrid manufacturing, is really an optimization and a lean way to plan, program, and then execute at the end a lean, automated manufacturing environment. And the second bullet is going back to what I said earlier in the VR and AR. It is reducing risk and produce first-time quality. And this, when we look at this equipment, if you program it and then you run into each other, the robots cannot control it. It's not only that you impact the production and production rate, it's also a high cost factor in your factory of the future. And it will be more and more automated. It will be more and more expensive. And it will be not a cheap fixture you have there. It's really an intelligent system. And then at the end, it is the speed for change. If you get a design change of a part and you want to update your robot program, this should be done almost automatically on a button push, that you get everything reprogrammed, validated, and then sent again to the shop floor. This is giving you really the power. This is giving you the speed of getting your future factory up and running. Then in the next lab is the virtual and real execution. And the virtual and real execution is showing the digital continuity and the loop from the engineering design, engineering manufacturing, planning to the execution, and then using new technology to loop it back. In this case here, for the drone, we developed at NIAR in the Innovation Center. On the left side, you have the digital manufacturing. We do your 3D work instructions. On the right side, you have the execution system, which you can use as it is on a large screen, on a tablet, to execute the work order. Or you can use new technologies, in that case the HoloLens, which is reading out the work instruction and interacting with the worker, explaining to him how to install it. And not only how to install it, but also capturing information and data from this, in this case, an assembly workplace, which then can be fed back into my virtual environment, then to optimize my processes, my work instructions, my sequence, and so on. Here again, it focuses on the first-time quality. It focuses on what kind of technologies can I give my workers at their hand, to say smart tools, yeah, or at their head. When we think about a HoloLens, to use augmented reality to execute there and to help to be faster, to be more precise on the quality, be more efficient there, learning from the shop floor, driving this optimization throughout the planning, the simulation, and then the execution. So I picked those 4 different stations to give you a little bit of an introduction on technologies, but also processes underneath and behind. All this sits on the 3DEXPERIENCE platform. So you can take your product, your system, your assembly throughout those different labs, yeah, in a connected fashion and manner, to really experience for each of the domains what does it mean to use new technologies and be innovative in the future. So what can the innovation centers provide to you? It is on the one hand side that you get an introduction to those new technologies out there and how we and partners would recommend to use them as a best practice going forward into the factory of the future. But also set up projects with us in different kind of horizons and discoveries, or take your idea, take a product you already think that you need to improve in the future, and go through the steps of designing it, planning it, and executing it in the factory of the future. Really, let's experience that together, and let's make sure that we can help you to be faster, to get it into your real facilities. So as a summary, we want to take you on your journey to the factory of the future and your strategy. And I believe that is, for every customer, it is unique in their own way. Then we would like to help and support you being at the innovation centers to drive those innovations from an idea, from a vision to a level where you can put it then out of the lab into your production environment. Also, we encourage all the partners and everybody who is involved there, from universities to customers and partners, to be open to network and collaborate. And there are so many great ideas out there. There are so many startups who get into that domain and the industry, and we have to leverage to be faster and smarter in the future. And then educate your workforce. And I said that at the end of the last webinar. I will do it again at this time. Take them on a journey. Take the young, fresh guys who live and dream already in that world. Take the seasoned guys who have all the knowledge, but usually are a little bit more hesitant. Take them all on the journey to your factory of the future. And do it now. I think this is the last message I wanted to get across. This is all established and set up there. The time is there, and everybody is looking at it, and take that advantage you have compared to your competitors to leverage all the knowledge and the technologies there. With this, I thank you very much. I appreciated that you took the time to go through 2 webinars with me. If you have any questions, you can either reach out to our webpage to get more information or just contact me. I would be more than happy to get back to you on an email, or just see you and meet you and go on your journey to the factory of the future and one of our innovation centers. Thank you very much. Back to you, Ellen.
Thank you very much, Enrico. And please do take us up on emailing Enrico with questions. He's great at getting back with you. or visit our website. And with that, this concludes part 2 of Considering Your Future Factory Strategies. We look forward to hosting new webinars on this topic coming soon.